Okay, so I'm going to continue by working examples straight from my math lab to see if that's more useful for you guys. So let's go through and work the odd ones for my math lab number 20. Again, realize that these may not be exact matches to the problem that you see because my math lab auto generates numbers, but they should be pretty close. And again, the whole point here is designed to give us practice with these new identities that we have. Okay, all right, so we're going to start with this one. Use the identities to find the values of sine and cosine of 2 theta if sine of theta is equal to square root of 3 over 7 and cosine of theta is bigger than 1. Okay, so to start with, I've written this problem up on the board, and I've also written up our double angle formulas. Okay, so that's what we're going to use to try and solve this problem. Now, the first thing that we're going to want to do for this particular problem is just figure out what cosine itself is. Because notice that all of these involve some cosine of the angle itself and some sine of the angle itself. We know what sine of theta is, right? Sine of theta is square root of 3 over 7. Let's see if we can use that and the fact that cosine is bigger than 0 to figure out what our cosine is, okay? All right, so if we know that sine of theta is equal to the square root of 3 over 7 and cosine is bigger than 0, there are 2 ways that we can figure out what cosine is. One is just by using the Pythagorean theorem, okay? Or the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. We know sine is the square root of 3 over 7. So that means that squared plus cosine squared equals 1. Squaring this, the square root of 3 over 7 squared is 3 over 49 plus cosine squared theta equals 1. Subtracting 3/49 from both sides is going to give me cosine squared theta equals 1 minus 3 over 49. Well, 1 is 49 over 49 minus 3 over 49. 49 minus 3 is 46 over 49. So this tells us that cosine squared of theta is equal to 46 over 49. To get cosine by itself, we take a square root of both sides. Now remember, when we take a square root, we technically get 2 answers, the positive and negative root. So cosine could either be the positive square root of 46 over 49 or the negative square root of 46 over 49. But we're told that cosine is positive, so our cosine is going to be equal to the positive square root of 46 over 49, which, since 49 is a perfect square root, we can think of the square root of 46 over 7. Real quick, thinking about 46, does the square root of 46 simplify? 46 is 2 times 23. No, it does not. Okay, so now we know that our sine of theta is equal to the square root of 46 over 7. Okay. Now, we could have gotten that another way. We could have gotten that by using just kind of a right triangle. So let's just look at another way to do this if you prefer a visual method for doing this. Okay, let's think about drawing in an angle in standard position where the sine of theta is equal to the square root of 3 over 7. Okay, sine is positive in these first 2 quadrants, right? This is a positive value. Sine is positive in these 2 quadrants because sine is equal to y, right? We also know that cosine is bigger than 0. Cosine is bigger than 0 in these 2 quadrants. So if we want both sine and cosine to be bigger than 0, that means we're going to have to be living in quadrant 1. So I'm going to draw an angle in quadrant 1. So here's our theta. Okay. If I drop in the reference triangle for that theta, here's our reference triangle. Okay. Now we know that sine of theta is square root of 3 over 7. We know that sine is y over r. Okay, so that means our y is going to be the square root of 3. Our r is going to be 7. So r is 7. Square root of 3 is our y. Can we figure out what our x is and then use that to find cosine? Sure. We're going to have to use Pythagorean theorem, just like we used the Pythagorean identity before. Pythagorean theorem says x squared plus y squared, which is the square root of 3, squared has to equal r squared, which is 7 squared. So x squared, square root of 3 squared is 3. equals, 7 squared, which is 49. Subtracting 3 from both sides gives us x squared equals 46. Square rooting both sides gives us x equals the square root of 46. Again, it's the positive root because we're in the first quadrant. Okay. Now cosine is equal to x over r, so this tells us that cosine of theta is equal to the square root of 46 over 7, exactly what we got the other way. Either method will work, and either method is perfectly fine. Do whatever makes your heart count. Okay, so now that we know what our cosine is, we're going to figure out what sine of 2 theta and cosine of 2 theta is by using those double angle identities. So let's start with sine. Okay. So to calculate sine of 2 theta, we're going to have to use this bottom identity. So we're going to have that sine of 2 theta equals 2 sine of theta cosine theta, just replacing our a's with theta there. Okay. And now we know what sine of theta is, square root of 3 over 7. We know what cosine of theta is, square root of 46 over 7. We're just going to plug in. Sine of theta, square root of 3 over 7. Cosine of square root of 46 over 7. And now we get to simplify. When we multiply fractions, we multiply numerators. 2 times square root of 3 times square root of 46 is 2. Square root of 3 times 46 is 138 over 7 times 7 is 49. Let's make sure we can't simplify that square root of 138. Square root of 138, let's see, 138 is 2 times 69. Neither one of those are perfect squares, so this is going to be our answer. Sine of 2 theta is going to equal 2 square root of 138 over 49. We need to figure out what cosine of 2 pi is. All right, well notice that for cosine, I have several different versions of the double angle formula. Here's the thing, it does not matter which one you use. So use the one that you feel is going to make your heart the most happy. I don't really know. Let's use this one just because it's above the one that we used before for no real other reason. Okay, so we're looking to find cosine of 2 theta. Our formula tells us that cosine of 2 theta is going to equal 1 minus 2 sine squared of theta. Okay, so all I did is replace our a's with theta. Now, as long as we know sine of theta, we should be able to solve for cosine of 2 theta. Well, 1 minus 2 times, what's our sine of theta? Our sine of theta is the square root of 3 over 7. We have to square that because in our formula we had sine squared. Okay. So 1 minus 2 times, when we square this, the square root of 3 squared is 3. The square root of 7 is 49. Okay. Excuse me. So simplifying, we'll have 1 minus 2 times 3 is 6 over 49. So 1 is the same thing as 49 over 49 minus 6 over 49. 49 minus 6 is 43. We end up with 43 over 49. So the cosine of 2 theta is equal to 43 over 49. Now we could have gotten that same answer using either of the other top 2 formulas as well. Okay? So really all we're doing right here is we're using a little bit of prior knowledge to figure out what cosine of theta is. If we know sine of theta, then that cosine of theta is positive. And then we're just plugging into these formulas. See? Let's look at another example. All right. So let's go to our next odd problem and take a look at what that is. All right, so use a double angle identity to find the exact value of the expression cosine squared of 105 degrees minus sine squared of 105 degrees. All right, well, I'm going to put this up on the board and then we can talk about it. Okay, so we're asked to find the exact value of cosine squared of 105 minus sine squared of 105. So looking over here at our double angle identities, we have one that involves cosine squared minus sine squared. We're going to use this version of our double angle identity. Okay, so cosine squared of 105 minus sine squared of 105 is going to equal cosine of twice our original angle, 105. Okay, so this is equal to cosine of 2 times 105, which is cosine of 210. Okay, 2 times 105 is 210. So then the question becomes, can we determine the value of cosine of 210? To answer that question, I'm going to go ahead and pull up our unit circle. Okay. So again, we're looking for the value of cosine of 210. So on our unit circle, here's 210. So our cosine is negative square root of 3 over 2. So our answer should be negative square root of 3 over 2. All right, let's go on to our next question. So again, I'm just trying to work the odds to give us a little bit of an overview. Use a double angle identity to find the exact value of the expression 2 tangent of 165 degrees minus, divided by 1 minus tangent of 165 degrees. Okay, so this is what we have. Well, we're told to use a double angle identity. Here's our double angle identities. There's only one that involves tangent, and that's this guy right here, right? So notice that we have 2 tangent of 165 over 1 minus tangent squared of 165. So A in our double angle identity here is 165. So what does our identity say? It says that this expression is the same thing as tangent of 2 times 165. Well, what's 2 times 165? Well, 2 times 165 is 330. So we're really asked to discover what is the tangent of 330. To answer that question, we can go to our unit circle. Okay, so here's our unit circle. Here's 330. Now remember that tangent is y divided by x. So tangent of 330 is going to be negative 1/2. Tangent of 330 is going to be negative 1/2 divided by square root of 3 over 2. Now, we know my math lab, right? My math lab is going to want us to simplify this. So when we divide fractions, we have negative 1/2 divided by square root of 3 over 2. But that's the same thing as negative 1/2 times 2 over the square root of 3. My 2's cancel, and I'm left with negative 1 over the square root of 3. Rationalizing that by multiplying top and bottom by the square root of 3 gives me negative root 3 over 3. So there's our answer, negative square root of 3 over 3. All right, next question. Express the trig function as just a function of x. Cosine of 4x. Okay, so cosine of 4x. We're going to have to step this down until we get just to x. What this means is we're going to have to use a double angle formula twice. So let's look at how we can do that. All right, here we go. So we have cosine of 4x, and we want to get this down so that we just have something in x, okay? So we have several different places to start. We're going to take this cosine and reduce it down, okay? I could use any of the top 3 to do so. I'm actually going to use this bottom one because it looks like the least complicated. This guy has both cosine and sines running around. This guy has cosine squared. I'm making the choice to use sine because if I have to do this again, my sine formula actually is probably the simplest of them all because it doesn't have another squared in there. So I'm going to start using this formula here. Okay, now I need to be a little bit careful. Okay, notice what this says. This says 2a becomes a. In other words, this becomes half, right? That's why these are called double or half angle identities, okay? So when I rewrite cosine of 4x using this, I'll have 1 minus 2 sine squared of not just x, it'll be half of this. What's half of 4x? Well, it's 2x. Okay, so now we're halfway there, but remember that our goal is to write this just in terms of x, not 2x. So what we need to do now is we need to rewrite this term here, again, using one of our formulas over here. Well, the only one that is going to let me reduce a sine of 2a or 2x is going to be this guy. if it's helpful for you at this point, you may want to think of this as 1 minus 2 times sine of 2x squared. Remember, sine squared of 2x and sine of 2x squared, these say the same thing. Okay? And we're going to rewrite this piece using this equation here. Okay? So I'll have 1 minus 2 times something squared. That something is going to use this sine of 2x formula to replace sine of 2x. So sine of 2x becomes 2 sine of x cosine of x. Okay, so good news and bad news is we're done. We now have this just in terms of x's. Bad news, if we look at our MyMathLab options, that's none of them. What did we do wrong? Did we do something wrong? So let's take a look. So here's our MyMathLab options. None of them look like what we have up there. Ugh. So what should we do? Well, the answer is we need to do some rewriting of this. Okay, all right. So to start with, let's do a little bit of rewriting simply by taking this squared and applying it to each term inside of here. So then we'll get 1 minus 2 times 2 squared is 4. Sine squared, we can write as sine squared of x, cosine squared. We can write as cosine squared of x. Now I'm going to distribute this negative 2. We get 1 minus 8 sine squared of x cosine squared of x. Now, unfortunately, this still doesn't look like any of our options. Okay, so let's take a look at our options. Now, this doesn't look like any of our options, but I did notice that I have an 8 running around in what I have on the board, and this bottom option seems to have an 8 inside of it. So I'm guessing it's going to be this guy, but I want to show it. And what I noticed is that this only has cosines, where what I have on the board has both cosines and sines. So what I want to do from here is I'm going to try to rewrite my sine. I'm going to rewrite this sine squared using our Pythagorean identity. Our Pythagorean identity says sine squared plus cosine squared equals 1, which means sine squared equals 1 minus cosine squared. Okay, so I'm going to do a little substitution. So inside here, I'm going to replace the purple box, sine squared, with 1 minus cosine squared. So that gives us 1 minus 8 times 1 minus cosine squared of x times cosine squared of x. So again, I just replaced our purple box with 1 minus cosine squared of x. And now let's again do some distributing. Okay, so I'm going to start by distributing this negative 8. 1 minus 8 times 1 is negative 8 minus cosine squared of x. I need to be a little careful here. Oh, okay, so the distributing here is going to be a little weird. Instead, what I'm going to do is I'm going to rearrange and move this cosine squared term in front. I think that's going to make it less confusing. So multiplication order doesn't matter. So 8 times 1 minus cosine squared times cosine squared is the same thing as 8 times cosine squared times 1 minus cosine squared. Okay. Now I'm going to distribute this negative 8 cosine squared into that 1 minus cosine squared. So I'll have 1 negative 8 cosine squared times 1 minus 8 cosine squared. Negative 8 cosine squared times negative cosine squared is positive 8 cosine to the 4th. Okay. And now I think we have one of our options there. Okay, so we have 1 minus 8 cosine squared plus 8 cosine to the 4th. And one of our options here, is 8 cosine to the 4th minus 8 cosine squared plus 1, which is the same thing we had, just in a slightly different order. All right. Okay. Write the expression as a sum or difference of trig functions.